Hello, folks. Welcome to Rational Science. Today we're going to be talking about temperature on our quest to find out what quantum mechanics has in store for us. We've covered force, mass, energy, and today we will look at one of the forms of energy, which is heat, temperature. What the hell is temperature? But before we do, let's get on with the extinction segment of our lecture, and that's got to do with human extinction and subject matters related to that subject. Okay, so here we go. Fella says, we do not have democracy, nor do we have a rule by the majority. Surprising. We have a republic which has representatives. Yeah. A minority who claim to do what the majority who voted for them want. Okay. In reality, they take care of their own self-interest when given a career in government. Yeah, I guess that pretty much summarizes democracy. The Greeks, especially people like Plato, they didn't believe in democracy. I mean, they concocted this form of government, but at least Plato thought it was the worst form of government. And I'm sure Socrates did as well. The worst form of government because they saw it as the rule of the mob. People who had no idea what government was all about, what handling money was all about, and they said, "No, you're not going to let all those bums govern. No, who has to rule? Well, you have to have the philosopher kings and queens today, right? Rule." And yeah, one thing that people are not aware of is that, you vote for politicians, they become the rulers, and then they allegedly rule over you. You've selected them for you. Okay, but what's the issue? The issue is that voting is not a right. There's no such thing as a voting right, the right to vote. And voting is not even a privilege. Okay, so neither privilege nor right. Voting is whim, just whim. That's all it is. It's not even a right for the politician. For the politician, voting is a privilege, receiving your vote. He comes to you and begs for your vote. Please vote for me. For him, it's a privilege to have your vote. For you, it's whim. If you want to vote for him, you vote for him. Otherwise, you vote for someone else or don't vote at all. Right has nothing to do in the whole picture. Voting is a right when you don't have it, when they forbid you to vote. But when you do have it, it's not a right. It stops being a right. It's not even a privilege. It's just whim. That's all it is. And so, what happens is when you vote, you are tacitly accepting to be ruled by someone. And that person, like this fellow says, once they get up there, they're not going to pay attention to you. I mean, they have a lot of constituents. How many do they have? Thousands, millions? You think they're going to pay attention to each one of those that voted for them? You thought this person was going to vote, was going to vote in Congress for, abortion rights. And it turns out that for whatever reason, he puts that on the back burner or doesn't care about it or votes against what you expected him to vote for. And you say, "Oh, what a traitor. He voted against what I wanted." That once they're up there, they do whatever they want. So there is no such thing as democracy anywhere on the planet, and there's never has been. And I'm not talking about the days of the kings and queens, 400, 500 years ago. I'm talking about even since then. There's never been a democratic country on earth. Once you vote for a group of people, they're up there and they do whatever they want. So in that sense, there is no rule of the mob, rule of the people. It doesn't work that way. Okay? People who rule, they rule up there according to their interests. And if it favors your interest, more power to you. That's the way it works. Okay? And this all continues. He says something else there. Let me see if I can get this thing up there. Let me put it here. And so what does he recommend? He says with blockchain technology, we could replace our corrupt republics. They're all corrupt always. So I'm not sure why we put an adjective such as corrupt when they've always been corrupt in the sense that they always rule for themselves. I mean, it's like overkill to put the word corrupt. Government is always corruption. Okay, it's very nature. No such thing as a government that is not corrupt. But it says our corrupt republics in the West with the direct democracy work. Each taxpayer votes on each law and regulation and tax on a blockchain voting platform. Yeah, you have these anarcho-capitalists, I call them narco-caps, and they truly believe that there's a future first for humanity, and that future is going to be internet, and everybody's just going to go through the internet and vote for any piece of legislation that comes to their desk or to their phone or whatever, and then it's going to be majority vote. Like we're 8 billion people, and there's no government. It's just everybody at home saying, "Oh, there's this issue." And somehow it pops into the public light, and everybody goes to their phone and votes, says, yeah, I like it. The other guy says, no, I don't like it. Will something like that ever happen? That's the Marxist philosophy. People like Karl Marx believed that there was going to be this dictatorship of the proletariat that would take us to the one world government. This dictatorship was just what it says, dictatorship. It was the workers who took over the means of production as well as of government. And eventually this would develop, it would evolve to a point where government was not needed anymore. It would cease to be. And that's what these people have reinvented with their little phones. They think everybody's going to get together on the planet, 8 billion people, and just decide from their homes what laws to pass, how to govern. Essentially, it's going to be an anarchy in that sense, in the best sense, not the anarchist who throws bombs, but anarchy in the sense that there is no government. No one rules over you, but everybody has as much power as everybody else. People think in these terms. They think that this ideal world someday will happen. And it just strikes me that they think it's real. In their minds, it's real, that it's going to happen. And no, I can only give you my 5 cents worth, and that is, it ain't going to happen ever. There's going to be no such thing as this, okay? Let me look at something here, okay? So no, blockchain, everybody voting through their phone, maybe in the land of the Klingons. And we're not going to make it, in fact, for what little time we have left here on Earth, okay? We're due for extinction. So this world in which everybody votes through their phone, yeah, great ideal. That's all I can tell you. Okay, another issue fellow raises says East Asians are really smarter. For example, they got 13% more brain size, but we ain't sure, okay? I looked it up to see if this is true or what the numbers say. And these are the numbers I find. There was a study some years ago. It says the average cranial volume among East Asians was 1.415 cubic centimeters, okay, compared with 1.362 for Europeans, 1.268 for Africans. I don't know if this was a racist study. It sounds like it, but if you do the numbers, well, the Asians are, about 0.04%, 4% bigger brain case than whites, like me, for example, and almost 12% bigger brain case than the blacks. Well, assuming it's true, does that make them more intelligent, smarter, because they have a bigger brain? I mean, it is also said that the Neanderthals, they had bigger brains than ours, or just about as big as ours. Were they as smart as we were? Well, certainly they did not develop beyond hunter gathering. We did a little better, right? That's one issue. But then, take the guy with the biggest brain in the East, and you bang him over the head with a hammer, and he's got a big lump there. He goes all wacko on you. He's got a big brain. Does that make him smarter now that he's got this big problem on his head than either a white man or a black man? I mean, I don't think that brain size is the factor that determines if you're smarter or not. And if you look at just history, right, you'll find that the West did better than the East. Was this because they were smarter? Meaning, did they have bigger brains in those days, 400 years ago, 500 years ago, when the Western world was way ahead of the Eastern world? And I can tell you that it's not the case. They were not smarter, and they were not. They probably didn't have bigger brains than we have today. What happened was that the West, for historical reasons, the way things developed, they did the countries like Europe did very well compared to the rest of the world, and so the rest of the world stayed behind. All of these countries in Europe were coming up. And if you go 1,000 years ago, it was the Arabs that were up there and not Europe. Europe was undergoing terrible times right after, Charlemagne and some of the other people who ruled Europe. Whereas the Arabs seemed like they had the world ahead of them, And it lasted maybe 600 years till about the days of Suleiman the Great, the Magnificent. And then from then on, the Ottoman Empire went down, and what came up were the Europeans. So were the Arabs with bigger brains, 1,000 years ago? Were the whites in Europe with the bigger brains 400 years, 500 years ago? And now the Chinese now are growing their brains bigger? I don't think so. I think smartness does not necessarily mean bigger brains. It just means that today we have our brains developed because of evolutionary processes, and any person on Earth, more or less, I can't say that any, because there are all kinds of people out there, but a great majority of people out there have enough brains, enough smartness, whether their brains are smaller or bigger, whether they are female or male, whether they are black, white, or yellow. They have enough smartness to understand anything that is taught to them. If God, Mother Nature, Father Universe, the devil, whoever comes down here, were to explain to us a theory of, for example, how the universe works, I think we would all pretty much understand it. We have enough smartness, enough intelligence to understand what's being said to us, or the theory. So I don't know about brain size. In fact, I think they did an analysis of Einstein's brain, and they didn't find anything unusual. So just keep that in mind. Okay, so there is no hardworking culture in the Western world anymore. And again, I don't think it's got to do with culture. It's got to do with the development. I think the United States has reached, and Europe, these two regions have reached their maximum potential. They've developed maybe as far as they can. And now all you have is marginal development. Whereas China, which was so far back, has made great strides in the last 50 years. Again, because they were so far back. Only because of that. Not because China has some special kind of people. It's just that the way history has developed on our planet is that, the Europeans and the Americans reached their maximum development, and now they can only progress relatively slowly. And part of that is because the population is not increasing as dramatically as it used to. And China is only catching up and their population is also stagnating, as the numbers seem to indicate, and they're going to reach some kind of leveling off as well. So I don't know. I don't think there is uh, this thing where they're smarter. We're all smart, okay? We're all smart enough to do economics. We're all smart enough to understand things, and it's got little to do with our brain cases. I think at this point, we have all the developed our brains pretty much as far as mankind will develop it. We have the intelligence to understand anything that God wants to explain to us. Okay, another comment here. Do you think China would conspire with the U.S. To concoct and release a virus, referring to the COVID virus? Um, well, I can only give you my 10 cents worth here again. The United States is pointing fingers at China, and China is pointing fingers at the United States. There was this meeting, I think in August of 2019, military people meeting in Wuhan, this supposed city in China where this COVID thing apparently got started. And what happened? The Chinese say that the Americans, the military from the United States, brought the bug made at in the secret labs there in Washington. They brought it over to Wuhan and spread it out there. And the Americans say the opposite. They say, oh, it was the Chinese who started this COVID in a lab and introduced it over there in Wuhan. And, you have these two mafias just pointing their fingers at each other. Who do you believe? Well, again, it's opinion. There's nothing solid anywhere there. And so one of the issues is whether this COVID is an artificial thing that was made in a lab or whether it came through the airwaves, nature. In the case of HIV, the AIDS thing, they claim it started in Africa. It was maybe hidden in the jungles, and someone went over there and got in touch with some monkeys, with some apes, possibly gorillas, and caught it and brought it to the world. Well, something like that could happen, that there's this bug out there and suddenly you come in contact with it and suddenly it spreads throughout the world because you are the carrier. That could happen. Is that the case with this COVID thing? Is it that someone just picked it up in Wuhan? From what? From the air? It was never caught and suddenly it starts from nowhere and I catch it and bring it over, is that the way it works? Or did someone prepare this thing? And all I can tell you is some of my suspicions about it. And again, I'm on the fence. I can't tell you whether this bug is real or not. I can only give you again my 5 cents worth here. And that's that I would think that China and the United States would not cooperate on such a thing as this. And neither would Iran and North Korea and Cuba and all these countries that are enemies of the United States. I don't think it's possible. Okay, it's possible, yeah, but I don't think it's likely. Okay, but the question then is, you have this bug and it comes right around the time of flu time. This is a flu time here, at least in the northern part, in the northern hemisphere. This is the fall winter era. And lots of people get colds and flus and so on because what? It's an endemic disease that we've gotten used to, and it periodically among us. Maybe it's the weather that changes, maybe it's the pressure, the humidity, and suddenly people get colds and they get sick for 2, 3 weeks. Some people even die, they get complications. That's more or less normal. I get colds every now and then, flu, whatever, okay? But for this other bug to come in at the right time that the flu comes around, it's kind of suspicious. That's one of the things that gets me to think that maybe this is, that maybe it's not real. Just coincidence that these two bugs come at the same time. And that's one issue. Another issue is that, you've got so many strains. When the, what is it, the what was this? The polio. The polio bug came out. It killed some people, and then it took a long time to get a couple more strains of polio. This COVID thing already has like 7, 8 strains in just a short time. That makes you kind of wonder: is this real, or is this something that the powers that be are introducing, saying, "Oh, we have a new strain. Maybe you need another vaccine. We need to implement more, masks and shots and PCR tests and all this other stuff." And so, it makes you kind of wonder, is this I can't blame those people who doubt that there's this bug out there because their reasoning is correct, in that sense. I mean, I understand what the theory of viruses that they develop, they enter the body, they do this kind of thing. It sounds like a rational theory to me, not being a doctor or whatever, right? That's not my line of work, and I care very little about diseases and health and all that stuff. But all I can tell you is that it sounds like a rational theory. But then at the same time, we have an economic theory, and that is that someone is making a killing out of this. Other people are suffering economically, right? And then this happens to come at the right time that the flu comes around. We have all these strains all of a sudden, and it turns out that because of all these strains that are out there, these different varieties or variations, they implement new measures. And that does make you kind of wonder. It is suspicious. Okay, that's all I can say for now. We might have to let it run a little while to find out if something more evident comes to our ears and eyes. But right now, that's what I have to think, that there could be some issue out there where these people are manipulating the world. Okay, someone is. Okay, now the other one is, I got 2 shots. The last one in September, and the booster, etc. And I got a little bit sick after the second one. Very, very light, very light. Little runny nose, a little sneezing, and very little throat. My throat hurt a little bit. A few days, and it was gone. And I think it was due to that second shot. That's what I think. I don't know. And the question is, some people say, well, now that you got the shot, they're going to control you, like, with a remote control, with the joystick, and they say, okay, Bill, move right, move left. I don't think so. At best or at worst, I'd say that what they did is put a little bit of poison water in my shoulder, right? And that's it. I don't think it did anything more than get me sick a little bit, if at all. I think it was due to that, but I don't know for sure either. But other than that, I don't think they're controlling us, with this saying, oh, now you got we've injected you. Now we can control you, with all these satellites and all this stuff. No, I don't think so. Okay. But some people do believe that. And they say, oh, they're not going to inject me. What is it? That movie, the Invasion of the Body Snatchers, more or less, they take over your body. I don't think so. But some people do think in those terms, and they don't want to get the shot because of something like that. No, I got the shot because I wanted to travel. In fact, it's interesting, and this is also something that makes you kind of wonder. And I'll just give you my testimony here, okay? I went to Iceland, Reykjavik, in, what was it, May? And they put me in prison for 5 days. I was under quarantine in a hotel. They fed me all that stuff, but I couldn't get out, okay? And okay, so they tested me, and I had no shot. The reason they put me under quarantine, I had no vaccine. I had not gotten the vax yet. When I came back to Germany, I said, no, next time I'm traveling, I'm going to get the vax because I don't want to go through all this hassle. Okay, so I go there, what was it, September I got the second shot, and 1 month earlier, around August, something like that, I got my first shot. Okay, so I had my 2 shots. I was ready to go. Okay, so I'm going now to Argentina, South America. And what happens? Before you leave, you got to get the PCR test. Okay, now listen to this. This is what actually happened. I'm going to be honest here, okay? So I go and go through all this rigmarole to try to get that PCR test. And the reason it was such a headache was that the Argentine government said, look, you got to fill this form online before you can travel to Argentina. Okay, so I filled out the form, and whoever programmed that did such a lousy job that you're on the first page putting all your information there, your passport number, all this stuff. And then it says, okay, press the button, now you can go to page 2. Okay, so I go to page 2, and page 2 never comes up. What it did was erased every bit of data that I put on page 1, and it told me to start all over again. Okay, so that was great, and I said, okay, let's do it again. I did it again and again. It erased the data and took me to page 1 again. And it did that 3 times. After that, I wanted to kill the programmer. Okay, so I said, well, I can't do this because the system has a problem. It turns out that 1 hour later, I'm not kidding you, 1 hour later, I received a message in my email saying, you can now go to page 2. 1 hour later. You know, like my plane's flying away and they say, yeah, now you can go to page 2 if you want. Okay, so I did the whole thing. Finally, I was able to get to page 2, finish the form. I printed it out just in case. I go to the airport and they didn't ask for it before I boarded the plane. So I get to Argentina. I get to Buenos Aires. And with my paper in my hand, I want to make sure everything was okay. And there were the authorities, $2 an hour people waiting there, and they ask you questions, and they asked if I had the vaccine. I said, yeah, here's the vax that I got, okay? And I said, I also got the PCR. I said, oh no, we don't care about that. Okay, so now I leave Argentina, and I come back to Germany. Again, you know, the German government says you need the PCR test. So you go get your PCR test, right? They do it in the nose over there, okay? And, you know, I got the document, I got my PCR visa, and I go to the airport, and I present my passport, my ticket, and then they say, and I say, oh, I also have my PCR test. And the check-in agent says, oh, we don't need that. Okay, so I come to Germany, I'm saying, well, they're going to ask for it here, maybe. Nobody asked for anything. And so the question is, here you can't go to a store here. You can't go to a restaurant unless you get the vax and you're certified. The police are on the street asking for this stuff. You can't even take transportation now since a new law came into effect unless you're vaxxed or have a PCR test. And it turns out that here I come into the country, just leave the country, come into the country, and nobody asks for anything. So I'm saying, hold it, what kind of controls are people having out there? I mean, the bugs are floating from country to country. Nobody's controlling that, but everybody's worried if you go to a restaurant and say, hey, are you vaxxed? So that's my experience. Right now, I have a lot of doubt of what's going on out there. You know, is something's wrong. They're not controlling anything. And so I don't know. You tell me. Okay. Yeah, I got a lot of doubts. And talking about Argentina here, one fella asked a question. He says, can you share your thoughts on what, if anything, is going on with Argentina? And the reason he raised that, he pointed me to this link. And I found a fellow who interviewed me a short while ago. His name is Ed Dutton, British guy. And he talked about Argentina and how bad things are over there. So this fellow says, you know, what's your take on that? Now that I was there for a couple of weeks. And all I can tell you is what I think. I think that Argentina is undergoing very terrible times. And what Ed Dutton is saying, that this is what the rest of the world can expect, what you see happening in Argentina. And I'll just give you a number so that you can see how bad things are, okay? You go with $1, okay? And if you exchange it with the government, they give you 95 pesos, not even 100 pesos. If you go out on the street, they give you 200 pesos, okay? Now, I always exchange on the streets. You never exchange officially in Argentina unless you're crazy, because you're going to lose a lot of money. You've always lost money, except one time where the dollar was 1 peso, $1 during a short period of time in the 90s. Other than that, you never go to Argentina and use your credit cards or exchange money with the government. You don't do that because the government's going to steal you just blind. And people say, well, you can't exchange on the streets because you don't know what you're getting. I've never had any problem. I never got a single bill that was fake, and you don't get them because they lose their customers. So it's the government who scares you and says, don't exchange on the street because they're going to give you fake bills. Well, even in the worst of cases, even if they gave me, half of my bills were fake, I would still be ahead of the government. Okay, because if half of my bills are fake, I still get 100 pesos per dollar, whereas the government only gives me 95. So even if they give me fake bills, I'm ahead. And of course, that never happens. I never got fake bills on the streets. And it just gives you an idea of how many problems they have down there. Just to give you an idea, for $1, you travel like 20 minutes, not kidding you, like 20 minutes with a taxi. For $1, 200 pesos. Unbelievable. Things are extremely cheap down there. And, a worker makes maybe anywhere between $200 and $300 a month. Within Argentina, that's in terms of pesos, they can work with that. But imagine if that person would have to travel abroad, especially go to Iceland, which is probably the most expensive country in the world, wouldn't be able to make it. So all the prices and salaries in Argentina are depressed. And you can spread that around in all of South America. South America is not doing very well. And what Dutton was saying is that the West is following Argentina. They're going to be in the same situation as Argentina in a few years or in a short time or whatever. They're following Argentina's lead. They're going out there borrowing money. Argentina owes like $50 billion. And they just go to the IMF and just ask for more money and pay interest, and they just do this over and over and over again. That's all they do. And there's no progress, there's no expansion of the economy. And so the question is the West following the lead of countries like Argentina? Are they just creating money with no growth? And is that sustainable? So this is food for thought for you. I agree with Dutton on this. I think Argentina is in terrible shape. I don't think they're going to get out of it. I think it's one of the first countries that is going to go under, but they won't let it go under because what they do is just go borrow more money and spread it around. That's all they do. And maybe the United States is doing the same thing. Europeans here, the European countries are doing the same thing. They're all just creating money. And where's the growth? Is this sustainable? Just creating money and just keep doing this forever? Is that what we can expect? Or is there going to be a collapse of the global economy? Which is what I'm saying will happen. When, not if, but when it happens, it's the end of man. My 5 cents worth. Okay, let's move on to temperature. And before I can get to that, let me give you a little introduction on energy, because some people seem to have still big problems with the word energy. They want to introduce energy at all costs into the discussion, and temperature has something to do with energy. So it's a good way of getting to the word temperature by going through energy. Okay, and so here's one fellow, and he says the following, okay? Gives you an idea of what these people are thinking before, or how they use the word energy in order to get other things done. But we have to destroy the word energy before we can get there, because we need to understand the word energy if they're going to be using this word every 2 seconds. We need to understand what that is. Okay, so a fellow says, weight is a measure of the pull of gravity. By the way, this is part of the same thing. Okay, it's also weight and mass, etc. We have weight, mass, energy, work, force, all these, and field. Okay, all these words are esoteric words. You know, they're words that mathematical physics has invented, and these people just use them liberally without really focusing on what is being said. Okay, because they're going to try to give physical interpretations with these words. Okay, so this fellow says weight is a measure of the pull of gravity on an object. Okay, very clear. On Earth, the downward force of gravity gives an object a downward acceleration of about 9.8 meters per second square. Mass is a measure of how much matter there is in an object. All he did is just do cut and paste and put it up there. Okay, we need to answer the questions, not simply cut and paste and say this is what mass is, this is what weight is. We already have these definitions by memory. It's a poetry, poem. That's all it is. What we need to do is answer the questions. These are the questions that people who use the words mass and weight have to answer. So let's make sure we understand what the issues are and what people need to answer. Okay, here it is. Okay, we have, is mass the quantity of matter? Yes or no? Okay, these are all yes or no questions that all religious, irrational folk need to answer, right? Is mass the quantity of matter? Does mass have anything to do with gravity? Okay, does mass have anything to do with speed? Because Einstein tells us that speed changes the mass of an object. Okay, and does the quantity of matter change with either gravity or with speed? And there you have the definition from the Wikipedia. Rest mass is an invariant quantity. Okay, what does invariant mean? It means it doesn't vary when it's at rest. So what are we talking about? Well, we're saying that the object has so many atoms. That's what they're saying. There's a quantity of atoms that forms something which we call the rest mass. Okay, fine. If that's the definition of mass, you cannot use it in the next sentence, which has to do with weight, which is what they call relativistic mass. It says is dependent on velocity. No, it can't be, because if mass is the quantity of atoms, the quantity of atoms does not change because something speeds up. So now they're talking about how that thing presses up against the scale. That's known as weight, not as mass. And so we have a problem because they're calling something which is known as weight, which it has to do with gravity or with pushing on a scale, and they're confusing that or using the word mass to define that. That's where the problem comes in. So this is what people have to answer. They have to answer, look, are we talking about mass or are we talking about weight? Okay? And so this is where we have a problem. These are the questions that people who use these words have to answer. They can't just continue to say, well, I'm just going to cut and paste and tell you that weight is this and mass is that. We already have that information. So there's no need to cut and paste anymore. Just answer the questions, okay? Okay, and here Paul continues and it says the following. It says, work is equal to force times distance. The formula doesn't change because of incline or decline. Okay, again, it does change, and I don't take my word for it. Here are 3 sites that I pulled at random, and they all say the same thing. Yes, it does change. The equation does change, and here are the equations. The equation is force times distance times the cosine of theta. In other words, you're looking at the angle in which the thing is moving. It's not the same thing to push something straight horizontally as pushing it up a hill or down a hill. These are different. You have to perform different kind amount of work, pushing it up, straight ahead, or downwards. Okay, they don't. Why? Because you're helped by gravity. That's why. And so you need that angle. You need to know what the angle is. And here you have another fellow says the same thing. Okay, again, all these are equations. Okay, that these people put out there, and you can see that this one also mentions cosine of theta. And there you see it. What is theta? Is the angle between the vectors, force, and displacement, way down at the bottom. So you need that angle, okay? And here's a third one, okay? If I can get it here, okay? And this is from the Wikipedia, okay? Let me get myself back in here. Okay, this is from the Wikipedia, and again it says the force times distance times the cosine. Okay, you need that cosine in there if you're going to push up a hill or down a hill. So no, the equation is not force equal force times distance. It's force times distance times theta. Now, if theta is an angle of 0, then it comes down to 1, and so you have then it defaults to force times distance. So don't listen to this fellow, because you're going to be misled into how the equation is about the factor known as gravity that influences an object that is being pushed. Okay, gravity does have an effect on that. And so, the equation really is with a cosine, not without it. Just be aware of that. Okay, moving on here. Let me get this out. Well, it says energy. Now we get to energy. Energy, the capacity. Defines it as the capacity. Okay, the definition, capacity to do work, is what? Conceptual. It's a concept, right? There is no physical object called capacity. Okay, capacity is a concept. Okay, no standalone physical object called capacity. Okay, but then this fellow continues, says energy starts the car, not the gas. So gas does not start your car. What starts it is this concept called capacity. And so capacity is what starts your car, not the gas. This is what people repeat without even thinking. These words have been shoved so much into their heads that they just parrot them, just say it. Oh, the energy that I have. And they use words of ordinary speech or notions of ordinary speech and introduce them into physics. No, hopefully in physics, it's gas that starts your car and not this concept called capacity, which he admits is a concept. Okay? And but he, chases his tail around. He said, we don't start the car with thoughts, ideas. Right, you're right. And abstract conceptual is thoughts or ideas, correct. And so you don't start a car with concepts such as energy, because energy, as you said, is a concept. Okay? And again, all this comes down to big definition, the word object, that destroys all their arguments. Once you define the word object, all these religions go down the drain, and they hate it. They hate it because they've been educated and they have all these theories based on these words, and suddenly you say, well, that's not an object, you can't use it for a physical interpretation. And it just kills them. It just kills all their theories right there and then, because whatever they say, whatever comes out of their mouth is irrational. And so, yeah, they have a problem with that. Okay, and well, it says here, it says, we literally use 25 different energies, meaning that energy is not a physical object. And here you see, if you look it up in the Wikipedia, you'll find all these little ghosts. You have mechanical energy and gravitational energy and magnetic ionization, chemical. Then you have the rest energy. That's energy when you have rest mass, quantity of matter. Okay. Chromodynamic energy, nuclear energy. Well, you have all these different kinds of energies. And today we're going to look at one of those at the bottom, known as radiant energy, because that's going to be the one that's going to create the heat, the temperature. Okay, so we're going to look at that radiant energy that these people talk about. Okay, and we'll get to that in a second here. But anyways, I just want you to know there's many kinds of energies, like saying flavors or maybe colors. The crayon is an object, but the colors of all these crayons is not an object. So if there are many energies, clearly energy is not a physical object again, okay? Because you have all these kinds of energy, mechanical and potential and kinetic and whatever. Obviously, energy is like an adjective. It's a type and not a thing in itself. Okay? So yeah, all these people have been brainwashed in high school, maybe in college, to think of energy as a thing, and they just took it for granted. Nobody even challenged that. And it's only when you put them against the wall that they realize that the mathematicians have created this concept and turned it into an object, because they give all the physical interpretations using the word energy, And people just use this word, you know, like the word spirit in traditional religions, and they just keep talking about energy. What is this energy? What is this thingy? Please draw it. I want to see it. Okay, so let's review some of these things that I just mentioned here, primarily related to energy. But it says energy is the catch-all word of math phys. Okay, that's what it is. They use it for everything. Whenever you want to fill in a blank, you know, in poker or not so much in poker, but in rummy and whatever, you have this joker, and you can put it as any word, any card in there. Well, this is more or less what the word energy is. It's a joker in every sense of the word. You can use it as any card you want. That's the problem with the word energy. Because whenever you don't know something, you just say energy and you filled in the blank. That's the problem. And what did we learn when we use the word energy? In fact, it probably hides more than what it reveals. And no standalone object called energy. Energy is the capacity. And yeah, we have all these energies. When it's treated as an object, what you're doing is essentially saying spirit. The spirit. My car runs with a spirit. That's what this first person said. yeah, I believe it. Energy, according to mathematical physics, is equal to mass times one of those two, either velocity or the speed of light squared, right? Which one is it? Is it the velocity or the speed? And that takes us to what I covered a couple weeks ago, where you have the velocity is when it changes, like when you have angular momentum, right? Speed, straight line, no problem. But velocity is no problem when it's in a straight line, but when you turn a corner, now you've had to accelerate. And the way they fixed that is saying, well, the speed did not change. What changed was the direction. And so direction is a qualitative concept. It's not a numerical concept. Therefore, they said, well, you have acceleration without an increase in speed. And so it's important because I'll tell you why. Because, you know, when Einstein says that you have warp space and you have this little photon that's going at 300,000 kilometers per second in a vacuum, and now it's going to go around the sun, it's going to turn a corner, it's going to change direction. Did it change its speed? Do we have a different value than 300,000 kilometers per second? And they say, no, the speed remained the same. What changed was the direction, okay? Because it's space that warped it, warped the path of that photon. That's the notion they have. And yeah, it has acceleration, but not because of speed, but rather because of a change in direction. That's the notion they have in mathematical physics. And that's important because, again, they're using acceleration to explain acceleration. Why? Because you have centripetal towards the center of the object, right? Where the center of gravity in this case. And what is that centripetal what? Centripetal acceleration, to explain why this thing changed direction, accelerated, but not because it changed its speed. What it changes its direction. Why? Because you have centripetal acceleration. So we have acceleration to explain acceleration to explain acceleration. Great. That's the way the mathematicians fix this. Anyways, there you have a little a, acceleration. And again, no change in speed. It's change in direction. That's how they fix that. We're not talking really about direction, distance. We're talking about distance traveled. Again, I covered that the other day. Distance, the separation between two objects, that belongs to physics. Whereas distance traveled is by one object. Okay? And so it's distance traveled is very different than distance of physics. And then force, there's only two types of forces, push and pull. And what is not either push or pull is tension. Tension, no one wins the tug of war, and that contradicts the definition of force, which someone does win the tug of war. Okay, so all these things, keep those in mind. That's in general what I've covered. You can go back and look at some of the videos, and they'll bring you up to speed on what the arguments are in more detail. Okay. Okay. Meanwhile, here we have electromagnetic radiation. We're going to talk about temperature today, and this is how it starts. And again, it's going to be related to energy. Energy, this spirit, this ghost. Okay. And this is going to be radiation energy. Okay. It consists of waves of the electromagnetic field. What the hell is a field? And I always like to say field is where the cows poop. That we all understand, that field. Okay? But this field is what you see there. All these little vectors, as they're known, these little arrows that you see there, blue and red. And what do those represent? Well, they represent magnitude and direction. The arrow, that's why the arrowhead is there, right? Represents direction, but the height of each one of those arrows is representing a numerical value. Okay, so if you look at those blue arrows there, for example, the first little loop there, you got 4 arrows, right? You see short arrows, bigger arrow, and small arrow, right? Well, the smaller arrows represent a smaller magnitude, and the bigger arrows represent a bigger magnitude. That's what they're saying, okay? And you got to think of this in dynamic terms, like the wave is increasing or the field is increasing, and then it dies down, okay? Let me say that again. It's going to be important, okay? The field is increasing, and then it dies down. The field increases, then dies down. That's what they're saying, okay? Well, it seems like something that's turning, you know, like if you look at the blue one here, okay? Well, the field is increasing as you go from here to there, right? Because, see, it's fatter in the center, and as you get to the edges, right, it gets thinner. You can see, like, let me get it here, okay? There, okay? You can see what happens as you twist this thing around, okay? Okay, this is what they're saying. They're saying that if you look at just the center here, what's happening? Suddenly it disappears from you, and it becomes flatter. Okay, and here you see more of the blue. Here you see less of the blue. So the magnitude goes to 0 at some point, and here it's at maximum. Well, it looks like they're talking about a rope. Okay, maybe this vector thingy is just a rope that's torquing. Could it be? Okay. And yeah, it says linearly polarized sinusoidal electromagnetic wave propagating in the direction through a medium, such as the vacuum. The vacuum is a medium? What is a medium in mathematical physics? I thought vacuum was nothing, space, void. And now they're saying it's a medium. So the nothing suddenly becomes a medium. That's strange. That's weird. But it says the electric field, right, oscillates. Yeah, here it is. If the blue one, yeah, I think the blue one is the electric one. I'm not sure right now. But if the blue one oscillates, well, what do you mean oscillate? Is this what it's doing? See, here you have 0 electric field, and here you have maximum electric field. It's oscillating, right? And the same goes for the magnetic field, the red one. Okay, so what we have is maybe what we're staring at, that all those vectors going to 0, it's just something turning in situ. Okay, I mean, I can just as well mimic that with a rope. Okay, okay. Here we have the dynamic version of that. Okay, same thing, but see, they show it going straight and the thing increasing and decreasing. You can see that's all they're showing, that it increases and decreases. Maybe what they should have done is twirled it around like I did with a rope, and maybe that's a better representation of what they're trying to illustrate there. Okay, it says the electromagnetic waves can be imagined as a self-propagating transverse oscillating wave of electric and magnetic fields. Well, the first problem is field. There's no physical object called field, because a field is just a bunch of vectors, and all that has to do with math and not with physics. That's the first issue. The second one is if it goes to maximum and then down to 0, maybe what we're talking about is something twirling in situ, in place. Okay, so this is what the argument's going to be. Okay, and of course, if we're going to relate that directly to temperature, Let's continue here. We have this situation here. The definition of the word temperature. What is temperature? You look it up. This is from the Wikipedia. Says a physical quantity. A physical quantity. I thought physical, under our definition, physical is the same thing as an object. Physical is that which has shape. That's what physical means in physics. Okay, so all these words, thing, object, physical, body, substance, entity, they all mean the same thing. Exactly the same thing. They're all synonyms, perfect synonyms. What is it? That which has shape. And quantity doesn't have shape. I don't know any quantity that has shape. Quantity is a concept. And so you either have concepts or you have objects. Okay, so quantity, physical quantity is a oxymoron. Okay, but let's continue. It says expresses hot, meaning heat, right? And cold. That's what temperature does. And then what does temperature also have? The manifestation of thermal energy. That's what temperature is. Manifestation of thermal energy. Even though the word thermal means temperature. Okay, great. What is energy? The capacity. Remember? So it's the manifestation of thermal capacity. That's what temperature is. Okay? The source of the occurrence of heat, right, is matter. What is matter? Any substance that has mass. What is mass? Quantity of matter. Chasing the tail around. Heat, the flow of energy. And at that point, I guess you have to pass go and collect 200 and go back to energy and start all over. It sounds like the Argentine PCR test. You go in a circle. Okay, so yeah, this is what you get. I mean, what do we have here? Energy has something to do with heat. Heat has to do with matter. Matter is the amount of mass, or the something that has mass. What is mass? The quantity of matter. And what is heat? Energy. And then you go back to energy and start all over and say, oh, what is it? Okay. So all they did was go around in circles. We haven't learned anything with all these words that mathematical physicists use. Certainly, we cannot relate it to anything physical, which is what we do here. We do physics here. We don't do math. We don't care about math. We want to understand how this universe works. We need the mechanisms of how Mother Nature does her stuff out there. Okay, so here we go with temperature. They say it's related to the vibration of molecules or atoms or whatever the substance is made of. Okay, if matter is heated, its temperature rises more and more. Okay, it can be seen that the particles contained in it move ever faster. Okay, no problem there. We're saying that the molecules, atoms, if you want, whatever the substance is made of, is vibrating faster. Why is it vibrating faster? What is what? Physical object, thing, physical, right? What thing is making the molecule move faster? That's what we want to understand. We're going to do physics here. We can't say, well, it just does, and here's the equation. We don't care about that. We want to know what physical object comes in contact with each one of those particles. And it turns out that, when if you see it there, right, when you look at that, you see that all these atoms or molecules, whatever those are, they're all connected by a little line there. I hope I'm not the only one seeing some lines there. Do you see the lines connecting the balls? All of them? 100% of them? What are those lines? I looked it up in the standard model and I couldn't find lines. So I don't know what those lines are. Yeah, we all understand that if you move, if you have two, let me move that for a second out of there. If you have this situation, right? Two atoms bound by something that, unites them, that binds them, that connects them. And this one moves, one of them, like the one on the right here, moves back and forth. This one's going to move probably in some way because of that. That we can all understand. Now try to do it this way, without the thing that interconnects them. Okay, so now I move this one. Why would this one move? See, it doesn't move. But here, if I'm holding tight and that thing is straight, in fact, it's better to do it with my magic wand here. okay, because that's fixed, okay? So if this guy moves that way, this one has no choice but to follow, okay? So this is the one I'm going to move, okay? I'm going to move it to my right. And if I'm holding on to it, it's going to pull. We all understand that. And vice versa. If I pull on this one's going to move. But without that thing in between, I can move this one and it doesn't affect this one at all. So yeah, the question that we have is, what are those, let me put this back in there, what are those little lines that they put between those alleged atoms or molecules? What are those lines? See, they put those things, you say, well, yeah, I understand that. Yeah, but you understand it, but that's because they put it there by hand. What are those little lines? Can you identify those things? Because obviously it's a thing. It's got at least 2 dimensions, I would say, maybe 3. Okay, so you got to identify those lines. That's the issue. Okay, and so this takes us to the spectrum, because they say that what that is has something to do with frequency. The freak of what? What freak is this? Okay, and here it is. Frequency is directly proportional to the average velocity of molecules. Okay, so that means if you increase the frequency, you're going to increase the average velocity of molecules. The higher the frequency, the hotter it is. The lower the frequency, the colder it is. Okay, but what is this frequency? The frequency of what is the question? Okay, this is what we want to understand. We want to understand the physics of this. Okay, so yeah, we see that, and here you see another version of that. Essentially, there you see it. It's the frequency of light, of this electric and magnetic fields. Okay, and again, what are we staring at? We're looking at a bunch of vectors. Okay, some are moving faster, the ones on the top, and those are identified as heat or hotter, and those are on the bottom moving slower, and those are identified with something that is cold. Okay, great. But what are those vectors? What are those arrows? Well, again, it's a bunch of arrows that form the so-called fields, and those vectors are just magnitude and direction. Magnitude and direction of what? What is it that we're talking about? What is this frequency, the thing that is going to move the molecules, the atoms or whatever that forms a substance that is heated up? We need to figure out what the objects are, the things that are moving the molecules. This is the issue. And so far we haven't learned anything about the physics of it. We've learned a lot of math, frequency, yeah, great. And what is frequency? Well, it's a bunch of vectors that move, yeah, that's the field, etc. All these are concepts. We still don't understand what is moving this thing we call a molecule, this thing we call an atom. What is moving it? And what are those little lines that unite 2 atoms? Okay, because yeah, if you put the lines in there, you can understand why one shakes the other one. But what is that line? Is that just put in there to fool you into believing that one atom is moving the other one physically because there's something connecting them? Yeah, we can all understand that if that thing is real. But what is that? They don't identify that. They identify the balls that you see there, which are supposedly the atoms or the molecules. But they never identify the little connection there. What is that? Frequency? Is that a field? Is that light? Is that electricity? Magnetism? What is that little line? Okay, that's what we need to get down to. We need to identify that little line. Okay, and so here we go. This is what a so-called electromagnetic wave looks like. Maybe the red one is electric field and the blue one is magnetic field, or maybe it's the other way around. It doesn't really matter, just color codes. Okay, but what you're seeing here, if you stare at it a little while, you'll find out that the blue one is kind of moving around. It's going to values of 0 and then increasing to bigger values. And the same with the red one. You would think that when it goes down to a 0, what you're actually doing is just twirling something around. I mean, doesn't that look more or less like this one? Here you see them again. You'll see what happens here. Give it a second. You'll see what happens if we turn this into something else. Doesn't that look like that when you're just twirling a rope? And here it is again. And doesn't look like it's just torquing in place. That's all we're having. That's all we're seeing there. Okay. So here you see them, one compared against the other so that you get an idea. Give me a second here. Okay, here you have it. Let me remove this one out of here. Okay, there you have it. Isn't that what you're seeing? It's not that it goes in one direction or in the other, it's just twirling in place. Okay, we have a representation using the rope for what these people call a wave, transverse wave, electric and magnetic fields. We say it's electric and magnetic threads. Okay, two threads, yeah, two threads that form a rope. They're physical, if we're going to do physics, right? Because otherwise you're doing math. Those vectors, that's not physics, that's math. They're magnitude and direction. So, we can have the same mechanism that we've had for the last 100 or so years, 150 years. The famous transverse wave, the one that James Maxwell described mathematically. And we can just as well replace that with a rope and get the same result. Okay, so we don't need these so-called fields, whatever fields are. Okay, we don't need these vectors, whatever vectors are. Magnitude and directions only. No physical object, just magnitude and direction. Those are mathematical descriptions. And yeah, when you put the rope in there, now you can see why, this is true here. The velocity of light is equal to frequency times wavelength, okay? And one exchanges with the other. The more you have, the more you torque it, okay? The more links you have for the same amount of rope, okay? So here, for that same amount of rope, you have fewer links and each link is longer, which is what you see there. And now here you have more links and each link is shorter. That's what that equation says. And yeah, now we can relate it to temperature because we can say, look, the longer the link, what we call the link length, not the wavelength, but the link length, the longer it is, the colder the substance. And the more torques you have, in other words, high frequency as they call it, lots of links, each link being smaller, shorter, now you have higher temperature. So this temperature thingy, we can relate to the rope because now we can say, well, yeah, if you have a higher frequency, like in the one on the bottom, the links are shorter, so that thing is moving quite fast. In other words, one little goosebump of those hits the atom much faster than the one on the top. The one on the top is moving slower in the sense that each link that arrives or that makes contact with an atom does not do it at the same rate as the one on the bottom. And now we can see why that would vibrate the atom in a lattice much faster than if you have a longer link. So it's this from a physical point of view, you can now explain this. Okay, you can explain why this molecule or this atom, whichever the two, because again, all molecules are interconnected with this rope. You can understand that, if you have this, and this is torquing, remember all this is at the speed of light. It's extremely fast, okay, compared to what we have in our macro world, okay. So if you have this situation, you can see why this would be hotter than something that is like this, undone completely. And that's going to be a cold influence, in other words, a slow influence on an atom compared to this one, okay? Because this is a higher frequency, more lumps, more links per unit of time or distance. So this is the issue. The issue is that one is going to give you more impetus, more impacts on an atom than the one that's got the longer link. And that would explain temperature. Whereas, in the case of mathematical physics, what physical object is coming in contact with the atom? And they draw those links, they put the little line, which is this, okay? We have something, we put a rope in there. What are they going to put in there? Are they going to put a vector? Are they going to put a field? Are they going to put a light? What physical object are they going to put between two atoms? What are those lines that form part of the crystal structure of, for example, a rock or whatever, quartz? What are those lines? And they never identify those. They might say it's a hydrogen bond. What is a bond? What do you mean a bond? Like James Bond or what? I mean, what is this bond? Is it a physical, is it an icicle, a string? What is it? And that's when they move to mathematics. They try to explain it mathematically. They just say, well, this is how it influences. It's a vector or who knows what word, esoteric word they put in there to fill in the blank. No, you have to identify the physical object. We're saying the object is a rope that interconnects any two atoms. The rope does have links, which is what these people call wavelength. We call it link length. More links, that's frequency. And now you can explain why one atom can influence another one and turn it into something hot, right? Because you have these higher frequency or more links getting to that atom than another influence, another rope that could have elongated links. That's the difference between them. And so, yeah, again, we have a physical mechanism, whereas mathematical physics does not. That's what it comes down to. Okay, we're going to go now into some of the questions people asked. Lots of questions regarding what an object is. And again, the word, what's my saying? The word object destroys all religions. And people have big problems with my definition of the word object because their religion dies. And of course, they never attack the definition. They try to, but their arguments all fall flat. And here are some of the arguments that they raise. So you can have a little fun with them. Here they are. Okay, here's the first person. It says, you're calling this thread concept an object. He's saying a thread is a concept. This invisible, intangible thread is an object. All threads are objects. So here's the answer, okay, to this fellow. You have to learn the basics, okay? Thread is always an object. Invisibility, intangibility have nothing to do with why a thread is an object. Think of a sewing thread. Is it an object or a concept? Why is it an object? Why is it a concept? I mean, you got to define the word object and concept, the category, so that we know what you're talking about. You can't just say, it's intangible and you call it an object. What's an object? You got to define the word object. And you got to defend your definition. Again, you can't go out there and use authority. You can't say, well, it's tradition. You can't use any of those arguments. Do you know of any sewing thread that doesn't have shape? I mean, if it has shape, it's an object. It's got nothing to do with invisibility or intangibility. And not because you can't see or touch a table does the table become a concept. I mean, if you can't see the table that the China man has on the other side of the planet, does that table become a concept just because you can't see or touch it? In other words, this person raises something that is totally irrational. Okay, and so these arguments obviously destroy his argument, his notion of what an object is. And here it raises another issue. Okay, it says, you're calling electromagnetic a concept. Absolutely. You say electromagnetism isn't an object. Correct. But this invisible, intangible thread is an object? Yeah. And so here we see the argument, the answer to this. Yes, exactly. Electromagnetic is an adjective. No such physical object called electromagnetic. An adjective is a qualifier of a noun. All adjectives are concepts. Do you know of any adjective that is an object? Do you know any adjective that has shape? Okay, so please mention an adjective that you believe has shape, and then you end the discussion. Very simple. You get a beer. Okay, another question raised or issue raised. Fellow says, what is this oxymoronic, invisible, intangible, physical mechanism thread made of? Okay, let's find out what it's made out of. It's made of this. Here it is. It's over here. Give me a second here. It's an irrational question. Okay, the single thread is an elementary entity. An elementary entity is one which is not comprised of anything smaller. Okay, there you see it from the Wikipedia. It says elementary or fundamental particle, because they deal with particles, a subatomic particle that is not composed of other particles. So it's irrational to say, what is an elementary particle made of? Because they're telling you that it's one that by definition is not comprised of anything else. Now, these people have mental problems because they don't even understand what they're reading there, okay? So let me repeat, an elementary particle is one that is not comprised of anything. Okay, that's where the buck stops. That elementary particle makes up everything else. Okay, and that's what the single thread is. It's an elementary entity. Okay, so the assumption is that there is an elementary entity that constitutes all matter. Should be the same for anything. Okay, again, it's this definition of the word object that destroys all these people's religions. They are irrational individuals, and they have irrational theories. And of course, when you define the word object, they say, no, but I don't like that definition because you destroy my religion. Yeah, no kidding. Okay, here's another fellow says, many objects take the shape of its container. These don't have defining shape. So what? I mean, does it have shape or not? It's not a question of what is the shape of. It's a question, does it have shape? It's a yes or no type of question, okay? Whether an object is molded by its container is irrelevant. Definition does not require specific shape, okay? Anything made of atoms had better have shape. I hope people understand that. If it's made out of atoms, it's got shape. I don't care what the shape is. It could be a gas that takes the shape of a given container. No biggie. No problem. We don't care. The point is the gas has shape. It's finite in its extent because the last molecule, the last atom is right there where you can see it, or if you could see it, right? If you had God's eyes. All gases and liquids have shape. Mereology, what an object is made of, is an unscientific definition of the term known as object, a thing, okay? So yeah, those are the answers. Here we have another one. Carl says, again, all these related to object, okay? Here it is. It says, I could say objects are that which doesn't have shape and be just as correct as saying objects are that which has shape. Okay, an object is 3D spatial, which we can see and touch, like detect, measuring, using technology, right? And shape literally has nothing to do with defining objects. Okay, that's what he says. So what are the answers? Well, there we have it. Unsubstantiated statements. All he said is, I don't like your definition. He hasn't justified why, he hasn't defended his position. He just made statements. Unsubstantiated statements. So you get an F for flunked. What arguments do you support those baseless arguments? Okay, that's the question is. And all you said so far is that you don't like the definition because it destroys your religion. Okay, what do you mean you could say that an object is that which doesn't have shape? What's the justification for that? That's just your opinion, your statement? Whereas, we're not making an opinion. We're giving you a definition. We're not saying you have to like it. We're saying this is the definition. And we defend it because we're saying that all objects in the universe have shape. Okay? And not all objects can be seen or touched. Now, you got to answer that. You either defend somehow the see-touch criteria and attack the shape. How, I don't know, that's your responsibility. But if all objects have shape and not all objects can be seen or touched, we're done. You lost. What can I tell you? You have no way of contradicting that. Okay, you have no arguments against it, and you can't bring arguments of authority, of democracy, everybody voting and saying, well, we have majority over here. We don't care about it. Science doesn't care about that. In fact, it's the other way around. Usually it's the fewer people who create revolutions, not the masses. Masses just follow. Okay, like you follow these fellows who came up with all that nonsense of see and touch. Okay, there are many shapes that aren't objects, and many objects that don't have shape. I don't know, name one. I mean, but here's my answer, okay? Until you define objects, we have no idea what that word means to you. Okay, so you need to define the word object and defend your definition. You can't use arguments of tradition, authority of democracy, and name one object, just one object that doesn't have shape. And I'll buy you a beer, okay? I promise. If you can name one object that doesn't have shape, it's one that I'm not aware of, maybe not on this planet, maybe it's on your planet over there in the land of Lululand, okay? Yeah, I don't know of any object that does not have shape. But if you know of one, please mention it. Yeah, put it down. Very simple. Because I'm saying it's a universal property. All objects have shape. Okay, and so the ball is in your court. Okay, another issue is related again. You can treat groups of objects as objects themselves. And a table is no more a true object than a flock or a pair or 100 cars. Okay, again, Mariology. Okay, the ensemble is a concept, not an object. Correct, you're totally right. We've said that many times. You have the word forest. Forest is not an object. It's a bunch of trees. That's what the word forest means. Now, the kid in kindergarten, he paints a forest. Maybe he just paints it green, a region, and the teacher says, well, what is that green stuff? And he says, it's the forest. He's treating the whole thing as an object. You're not supposed to think of it as a bunch of trees. You're supposed to think of it as a region, which we'll call forest. Only in that sense can you say the word forest represents an object, because you can point to that whole thing and that thing is called forest. But if you go in there and say, well, what is the forest made of? Well, it's made out of trees. Then now we're not talking any longer about an object. Now we're talking about a concept. And the same with, for example, a loaf of bread. Loaf is a single thing. If you say loaf and you point to it and say, instead of bread, you say loaf, that's fine. The loaf refers to that object. But if you're going to cut it up in pieces and say, well, the loaf is made of many slices, now you're not talking about an object. So the context is very important here. Okay, you can't keep switching context. Okay, an object is made of a single piece for the purposes of physics. When you point to a table, you're not thinking of, oh, it's got 4 legs and it's got one top, and no. You're pointing and you're saying table. The word table represents the whole object as if it were made of a single piece. You don't say, well, how many atoms does it have? How many molecules? How many legs? You don't go with all that. You point and you name the whole object. And that's how you treat gases. You say air. You point to the air in a balloon, you say air. And that air there is a physical object. It's made out of atoms. It's got shape. It had better be a physical object. Okay, by definition. Now, if you don't like the definition, your job is very simple. You have to start by providing an alternative, one we can sink our teeth into, because we can't do physics without an object. You can't do mechanisms without an object. So I know it hurts, but you got to come up with a definition before you challenge. You got to say, look, this is my definition of object, defend it, and then we can compare notes. You know, I bring that which is shape, that which has shape, and you bring yours, whatever definition you've got, and let's see who stands in the ring, who remains alive in the ring. Okay, that's the way it works. Okay, you got to have a good mousetrap to beat the shape definition of object. And yes, the definition of object destroys all religions. No doubt in my mind about that one. Okay, one fellow says, if one thread connects the pencil to every atom in the universe, wouldn't the pencil fall in every direction. Well, again, this fellow apparently hasn't taken a minimum of mathematical physics. He should, maybe when he gets to high school, I don't know, maybe he's in kindergarten right now. But yeah, obviously, you got to take a little bit of mathematical physics to understand why that's not the case. And here it is, okay? You have, it's an irrational conclusion, you have distance, okay? Remember, you got distance squared there at the bottom, the denominator. Okay, the moon has many atoms, but it is far away. Now it's the issue of distance. So your pen is closer to the Earth, much closer than it is to the moon. So even if the moon were bigger than the Earth, it would still be overruled by the distance. Okay, because distance is a very important parameter in that equation, meaning distance separation, not distance traveled, okay? And then you have Mach's principle. You have stars there, and you know, stars, each one of those stars certainly is much bigger than the moon. But they're so far away that even the moon pulls on the pen more than those stars do. Why? Because of that d squared in the denominator. Okay, so the distance is very important. If that distance is the separation between the pen and the star is much, much, much greater than the distance between the pen and the moon, well, that denominator just kills your whole numerator. I mean, you're going to get a number this small. That's how, what the tension is going to be. It's going to be very small. Okay, that's what the T stands for, tension. Okay, so I think it's straightforward. Distance is very important, meaning separation is very important. If you're far away, of course, the ropes are going to, you know, come together as if a single thread, a single coaxial. Whereas if the object is close to you, well, the ropes come from an angle. And yeah, the tug of gravity then, or the acceleration of gravity is much greater. Okay, another fellow says, your usual tactic of deflecting the merit of questions by obfuscating definition of object is simultaneously referred to parts and whole. Yeah, see, this is another mereology guy, okay? Two orbs don't touch because their surfaces only share a single location. Okay? When two Getty-style threads, elementary objects, intersect their surfaces, such as in electromagnetic interactions, what keeps them from fusing? See, touch, see, touch, see, touch. That's all they know how to say. They can't get away from that because they're confusing again, macro world stuff with Mother Nature's invisible agents out there, her secret agents. Certainly we can't touch gravity, you know, whatever gravity is. Yeah, I always show that. Pencil, right? You let go of it and it falls to the floor. But there's nothing here that you can see or touch. So hopefully whatever you propose is unseeable and untouchable, because otherwise you're not representing gravity. Gravity, the mediator of gravity, is unseeable, untouchable. Okay? And what do these people talk about? See and touch. And here they're saying, well, how come they merge, or how come they don't merge? How come they go through each other? And the interesting part about all this really is that they never ask these questions in the context of mathematical physics, because mathematical physics have been saying the same thing over and over and over for decades. They talk about superposition, one object affecting that one over there, occupying the same space, having two different states, meaning that, you know, you can have an atom vibrate and at the same time not vibrate, or vibrate less and vibrate more, both in the same place. And nobody questioned that. You have particles that can go through particles. No one questions that either. You have one particle at two places at once. Nobody questions that either. But as soon as you say, hey, we have the rope and they go through each other, they say, oh, what do you mean they go through each other? Well, why didn't you ask the question with the particles? It was the same situation. Weren't you aware that in the last 100 years, they've been saying that two particles can be at the same place at the same time? So please explain that before you attack the rope, right? Because that's been around for a lot longer. First, we got to destroy what the establishment proposes. And that's been around for a long time. So I haven't invented anything as far as untouchability and touchability, okay? But here's the continuation of that. He says, how do objects push pull if they can't touch without fusing? And again, this guy is taking everything out of context. He goes back and forth between context. Are we talking about quantum mechanics or RH, the rope hypothesis? Are we talking about particles or ropes? Are we talking about macro world or Mother Nature's mediators? Are we talking about definitions? Well, what's the context here, right? Atoms or mediators of forces, what are we talking about? And yeah, all I can tell you here, let me continue with that one. Here it is. Here you have two objects, okay? Let me get these out of the way. Here you have, let's see if we can go step by step one more time. I've done this the other day, but apparently some people are hard of learning. It's too steep a learning curve for them. Okay, so here we have two objects. Two balls made of a single piece, each one of them. So each one of that's all that God made. He just made two spheres there, white spheres in this case, each one made of a single piece. They're not made of atoms. They're not. This is a hypothetical situation, by the way, because this guy's going to take this out of context and who knows what he's going to come up with. Okay, here are two spheres. That's all God made. Okay, God's out of the picture now. Okay, he just made them left. Went to the fifth dimension, okay? So this is all we have in the universe. Two white, single-piece spheres, okay? It's not made of anything. Okay, now we have those two objects. Now we have, I got to specify that the black stuff is space. What is space? Nothing. What is nothing? Vacuum. What is all that? That which doesn't have shape. So that black stuff doesn't have shape. There is no container, okay? So these two things, these two spheres are in nothing. They're sitting there in nothing. They don't move. As you can see, they're not moving. There's no motion. All they do is just sit there. And they're standing there. We have no motion yet in the universe. And again, God went to made himself disappear. So there's no motion, okay? We have no motion, just two spheres. Do we understand the context, okay? Okay, now, again, hypothetical situation, and we're attempting to define the word touch. That's what we're going to try to do here, okay? Okay, so now God is going to set these things in motion. Okay, here it is, okay? And he waves his magic wand, and there they go in motion. Okay, we got that? Are they touching? That's the $1,000 question, okay? So God goes in there and boom, abracadabra, and sets them in motion. And when they meet, the question is, have they touched each other? Remember, single piece, they're made out of single piece, okay? And so here they are, okay? And so the question is, are they touching there? And my answer to that, again, is they're not touching. They can't be touching by definition of touch because you have separation between them. As long as they conserve their surfaces to each one of them, it's because they're separated or they're encapsulated in what we call space. In other words, they're not encapsulated, but there's space between those two objects. And as long as there's space between them, they're not touching. Because if there is no space between them, okay, then that means that you have this situation which is called touch, meaning they blended into one object. Now that it's a single object, we no longer have two objects. It's the only way you're going to get that situation pursuant to the definition of touch. Okay, so touch means that's not touch. Why? Because you still have two objects. And as long as you have two objects, that means each one is separated or encapsulated, if you want to use that term, in space. They're surrounded all around by space. We still have two objects. And you can press them harder and harder and harder. As long as there's space between them, you have no touch. There is not touch in that situation. The only way you're going to have touching is if you have them blended like that. They blend into a single object. Okay, do we understand the definition of touch? Touch means that two objects have blended in such a way as to become one. What's the issue? The issue, this is a hypothetical situation which this guy takes out of context every time, because he takes it out of context because he says, well, what do you mean about atoms? And we're not talking about atoms. We're talking about the definition of the word touch. And it has to do with this situation, hypothetical situation, in which we have two objects made of a single piece that the only way they can touch is if they become one somehow. They merge, they blended, whatever. However you want to think of it. I don't care. But the point is, the only way we're going to have touch is if they become one object, a single object. As long as they remain as two distinct objects, it means space is still separating them. And I'm not sure how else to explain that to you. Okay, so if you don't understand this, you got a mental problem. That's all I can say. Okay, just that simple. Okay, moving on here. Next issue. Fellow says, oh, well, hold it. So here, for real world scenario, okay, we're saying that two hydrogen atoms, under the Rote model, the atoms are woven, right? They're weaved by threads, the same threads that make up the electromagnetic rope. And so when the two atoms come close to each other, they can either bounce apart or they can blend into each other, like screw into each other. Okay, and that's the situation down at the bottom where they form the H2 molecule, which is a figure 8 type of entity. And yes, you can say those two atoms have become one. And in that case, you do have touch, because it's the same thread that's now coming from one atom and going into the other. Okay, do we understand that? That's a situation in which you have blended shells, electric shells, okay, electron shells, and yeah, now you can talk about touch. These two atoms have touched in real world scenario. That's the context here. Not the same context as before. This individual constantly loses track of the context. That's 99% of his problem. He loses track of the context. So you gotta, so if you're gonna ask a question, make sure you get the context right. If you're gonna write a paragraph explaining the context that you're talking. You can't just say, well, how about this, and you mean touches that, and this and that. You know, you can't. You gotta specify exactly if you're talking about a hypothetical situation, if you're referring to the definition, if you're referring to real world scenario, what is the context? Okay, moving on here. Moving on. Here we have, a fellow says, lots of questions again related to object, because again, their religions are being threatened here. Okay, if I can put any object I want in gravity, put the ropes in gravity and demonstrate that gravity works on them. No, it says, if I can put any object I want in gravity, put the ropes in gravity and demonstrate that gravity works on them. Again, it's a scarecrow. Okay, it's a straw man argument. In science, we don't demonstrate, first of all. We don't demonstrate anything, okay? We don't run experiments. We don't present evidence. We don't prove, okay? Because that's only, the intention of that is to convince, to persuade the jury. That's what it's for. That's what all that evidence is for. We don't do that in science. We do that in Sunday school, okay? That's the first issue. But then, who said you can put any object you want in gravity? Where did he get this? Again, it's a straw man argument. He says, if you can put any object you want in gravity. Who said that? Where did you get this, that you can put any object? Okay? And again, does gravity act or pull on the mediator of gravity? Does gravity pull on gravity, whatever gravity is? Okay, so where did you get this thing, that gravity pulls on gravity? Okay, please prove it. Okay, yeah, I don't know. Some people have quite a struggle with all this, because suddenly they see their religion in front of their eyes die a sudden death. Okay, another fellow says, nature's elastic bands. How do the elastic bands work between atoms miles apart in the real world? Elastic bands? Where did I ever say that the rope is like this rubber band? Hope you can see that. No, The rope does not stretch. It's made. The thread is made out of a single piece, meaning there's only so much matter in the universe. If we were to untangle every atom, if we were to untangle every rope, we would end up with a single closed loop thread that looks more or less like this, but not like the stretching, but think of that as a single piece, okay? And so it doesn't stretch. And this would be all the matter in the universe, okay? Everything from here would turn into atoms and ropes, all the way down the line. Okay, so it's a single thread and it doesn't stretch. So this notion that people get that there's some stretching, that gravity is some pulling thing that it stretches. No, gravity is, every rope only has tension, okay, between any two atoms. But the many ropes is what causes this acceleration, because as an object approaches another, the ropes fan out, okay? So I'm not sure how much more I can clarify that. I've beaten that horse to death. It's a dead horse that I'm beating to death. Okay, another fellow says, you never actually define rational. You just make a list of theories and say if they are rational or not. Magically, it is only you, your theories, and yours alone that happen to be rational. See, they make all these false accusations. No, here it is. I defined irrational because I think it's more profitable to define irrational than rational, but it doesn't matter because rational would be the opposite in this case. And here are the definitions of the word irrational. Okay, so we did define this. Criteria for defining irrational, again, for the purposes of physics, not for ordinary speech. Okay, straightforward, okay? Treating concepts as objects, known as reification, concretization. That's the 99% problem with irrationality. All people who turn all these concepts such as energy, mass, field, etc., into physical objects, they are irrational individuals, okay? Then you have the inconsistent definitions or undefined words. Anyone who uses the word energy, mass, field, force in such a way as to treat them as physical objects, or don't define them to begin with, because that's another issue. A lot of these words are undefined. They're declared to be undefined by the mathematicians themselves. The words point and line, they say, are undefinable. They don't know what energy is. They say that they have different definitions for the word mass, etc. So when you have that, you have inconsistent or definitions or undefined words. That's also irrational. We cannot follow your presentation if you're going to have two notions of mass. One as mass, the other one, or say, for example, rest mass, and the other one as relativistic mass, meaning weight. You can't have two definitions for the same word. And that's what mathematical physics has done. And all these people have just memorized all this stuff whatever monastery they learned in. And then the theory is inconsistent or doesn't follow from the assumptions. Okay, so we do have a definition for irrationality. Doing what mathematical physics does, which is describing and claiming to have explained. No, a description is not an explanation. Explanation is not a description. And then you have a mechanism proposed doesn't work or cannot even be imagined. I mean, warp space-time? What the hell is that? What do you mean, warp space-time? Again, it's in usually treating a concept as a physical object. Singularity, like a black hole singularity, it moves stars around. You cannot even imagine a concept moving an object, which is what these people do when they use the words energy and mass and so on. They're saying the mass did it, the energy did it. What does that mean? Come on. Okay, and here you have we just want to clarify that supernatural theories are not the same thing as irrational theories, okay? Supernatural theories, that's when they bring up all these spirits and ghosts and angels and stuff like that. And usually it's the traditional religions that use supernatural things. What's the difference? The difference is you can imagine God. if God is an object, a thing, a guy with four legs and nose and a mouth. Well, then we can all imagine a bearded guy up there moving his magic wand and saying abracadabra. We can imagine that. Okay? We're not talking about belief here. We're talking about whether we're going to understand the theory. And the guy says, look, imagine there's God. Okay, I can imagine God. He moves his magic wand, says abracadabra, and creates the universe. We can all imagine that. I can make a movie of that. Okay, I can make a movie of that. Irrational theories, you can't even make the movie. Why? Because you're using a concept. You're saying space-time. You're saying singularity. You're saying particle. And you say, oh, you mean a little dust, a grain of sand? Is that what you mean? No, that's not it. I mean the collapse of the wave function. How can I make a movie of collapse of the wave function? What am I going to put on the screen? And that's the difference between supernatural and irrational theories. Supernatural theory is imaginable. You can make a movie of it. Irrational theories, you can't even do that. All of mathematical physics falls under the second category, irrational theories. And that includes everyone, even the dissidents like the electric universe and John Chappell group there, Walter Russell, Tesla, Nikola Tesla, all these people, they did all the same thing. They worked with concepts. They turned them into physical objects. So they talk about charge. What the hell's charge? Please draw a picture of charge. What are you going to draw? 1.6 times 10 to the minus 19 coulombs? Is that what charge is? Charge on the electron? You're talking about an adjective, or an adverb at best, and you're saying that does something. The charge moved. What moved? The number moved? The value moved? So this is why anyone using these words such as charge, energy, field, mass is using irrational language. You cannot make a movie of their mechanism. And what we're trying to explain are the mechanisms of the universe. That's why they're irrational. Okay, another fellow says, do you have any experimental physical data confirming your rope hypothesis? My poor guy. In science, we do not do experiments. Never do we do experiments in science. Science, we explain them. We don't do them. Okay, let someone else do them. Let them do them in the land of the Klingons. You can do whatever experiment you want in your basement. We don't care. Go ahead and do your experiment. When you come to the conference, we don't want you to describe your experiment and say, this is what I measured. We don't care about that. We want you to explain the cause, what caused your experiment to have such and such result. That's physics. But to say that that you did an experiment, well, yeah, I did experiment. I let go of the pencil. There, do it a second time, repeatable, there it is. And so we did an experiment. Is that science? Because I did an experiment? No, you got to explain why, the cause, the pen fell to the table, to the floor. That's where you have to use your brain. But to say you did an experiment, and here's the description, the pen or pencil fell to the floor. Great. And what did we learn? Well, it fell at such and such rate. Great. What have we learned? I mean, that's a measurement. That's it. It's like saying I measured a table and it measures 1 meter. Okay, so you measured, and that was the experiment. That was the observation. There's nothing more. I mean, well, what is that? That's science? Okay, and then science, we do not confirm anything. Confirm means you are convinced of something. Confirm means you believe. You have an opinion. That's all confirm means. In science, we do not do opinions. That's done in religion and on Sunday school. In science, we have to explain the mechanism, physics. Confirm evidence, proof, persuading, all that stuff. Confirm is religion, opinion, belief. That's what confirm means, okay? In science, we do not collect data. So I don't know what this guy wants to collect there, okay? Especially this thingy you call physical. What do you mean physical? Experimental physical data. What is physical data? I have no idea. Physical, again, that which has shape. That's what physical means in science. And data doesn't have shape as far as I'm concerned. Last time I checked, okay? Maybe if I drink sufficient beer, maybe data somehow takes on a shape of some kind. I don't know, but I haven't drank that much beer, at least lately. Okay, so no such thing as physical data. Okay, physical means shape, that something has shape, and data does not have shape. And it wouldn't matter if it did, because it would be irrelevant. Okay, in this side, we do science, not mathematics, and please try to learn the basics. Okay, yeah, that's what you got to do. Okay, a couple more issues here. Paul says, what strikes me is the fact that people can so readily believe in irrational physical interpretations. Absolutely. For example, why is it that the concept of one-dimensional figures or time travel makes sense to the layman, despite being totally irrational? We can only imagine objects. Absolutely. You wonder why people have no problem in believing irrational stuff. They believe in time travel, maybe because they love the idea, being able to travel back in time. I mean, I love it too. I love, fiction. No problem. I mean, I enjoy it. It doesn't mean that you're going to bring that into the real world of physics, of explanations. This time travel is nonsense. For example, that's just one example. But again, these people have no problem believing in irrational theories. The mathematician from Cambridge and from Oxford and from Harvard, they tell them, "Oh, I got a PhD, and this is what I'm going to tell you. I'm going to tell you that there's something called a singularity that moves stars around. We proved it." And you say, "What do you mean a singularity? You mean a mathematical concept is moving a star far away? How did it do it? By what mechanism?" And they have no problem believing this and say, "Oh, black holes have been proven, and here I have the proof and evidence and blah, blah, blah." And they have no problem believing that nonsense. They have no problem whatsoever believing that nonsense. And don't even dare to attack their theory. They'll burn you at the stake, okay? Okay, and finally one fellow says, there's no such thing as nothing. Yeah, that is true, because nothing is the opposite of thing. Okay, so yeah, you're right. There's no such thing as nothing. Good, love it. But then he says, the first sign of wisdom is that I know nothing. That's a sign that you're ignorant, not that you have wisdom. Who was it? I think Socrates say, all I know is that I know nothing. No, that wasn't a sign of wisdom. It's a sign of ignorance. It's known as ignorance. In science, we do not use the word knowledge, okay? Because knowledge is just belief. Belief is opinion, and that's what knowledge is. When you have knowledge, it means you have made your position clear, that you believe in something. That's all that knowledge means. No, in science, we don't care about knowledge. What we care about is explanations. In physics, explanations of mechanisms. You have to explain a mechanism, and that's especially of the invisible mechanisms that Mother Nature has out there, and that's when you have to use your brain. That's when we know that you use your brain, okay? But to say that you travel through time, or that, who knows, that a singularity moves a planet around, and you cannot explain the mechanism, you just say, I believe in it because we've proven it, because it's knowledge. No, then, yeah, you can really say that all you know is nothing. All you said is that you know nothing, that you're an ignorant person. That's what it comes down to. Now, in science, we do not deal with knowledge. We deal with explanations. And once you explain something, the other person has to understand it. One way of doing that is illustrating your theory, your mechanism, and everybody can see it there in front of them, and watch the movie and say, okay, I understand what you're proposing. Doesn't mean they're going to believe it. It just means they're going to understand it. That's where science ends. What continues is religion. With that, I'll see you next time. See you then. Bye-bye.